Hello guys, I'm Naval Yemul. Welcome to my YouTube channel. In this video, we are going to see about the big data file formats and how the documentation of this big data is in your PySpark and how we are going to load that file into our Databricks, and we start reading by using a reader API, and we'll do the transformation on that, and then we write that data into a table or any other format. So these are the commonly used big data formats, file formats. So if you talk about CSV, TSV, these are nothing but comma separated values and tab separated values. And there is one more Avro file also. These all are a row based files. So row based means, I'll just give you an example. Suppose if you take a row here, like a table, you have rows and you have a columns here. So your ID, name, state and age. So suppose we have four students here or four employees here or four scientists here with their age. Suppose there is a we want to upload the fifth scientist. He is 104. His name is, we will put his name. It will be adding in a row wise. So these all file formats will be in a row wise. But there are few more file formats that are columnar based. For example, parquet file, you can pronounce it as parquet or you can pronounce it as parquet. But T is silent here. Most of the time we call it as a parquet. Delta and ORC. These are column based format. So here you cannot read the data like on your with your eyes. You cannot read the data. It is not a human readable format. But behind the scene, if you see how the data is stored in this format is based on column based. So you can see you have column wise data. Your data is getting stored in this way, and suppose if the new scientist come, he will be adding in a column wise. You can say if there is 104 scientists coming in, he will be adding a data here. Okay, so let me show you. Yeah, so he will be adding the fifth column here, but in the row based he will be adding somewhat like this, and this is a human readable format and this is not a human readable format. But when we are working on the PySpark, we need to see what are all the big data file formats, and we are going to read and write all this in our sessions, okay, using a Databricks data frame. Okay, suppose if you want to read a CSV file, let us start with the CSV file. So I'll be referring a documentation in the PySpark documentation here in the API reference of reader API. So here we have, I'll be giving you the link for this also. You have data frame dot reader dot csv. So if I open it, so this is the documentation regarding how to read a CSV file. There are so many options. You can see there are so many options. But if you just scroll down, you can see the parameters. The mandatory parameter is your path. So you can pass the path in a string or in a list. That is mandatory. You can give a schema, that is up to you. It is optional. You can give a schema by string, or most of the time it is given the schema by a struct type. So now we are familiar with the Spark data types. If not, please watch the recordings. So schema is optional, and there are so many other parameters that are an option. So if you want, you can just check on a new tab, data source options. So if you are reading a CSV file, these are the options. So by if you have a separator, by default it is a comma. If you are reading a tab separated, we need to give a mention that hey, the separator is tab here, not a comma, because the default separator is comma here. Okay, and this separator is used for reader and writer both. Okay, and you can see you have a quote, you have quote all, you have escape, you have comment, you have header. Now you can see header by default it is false. By default it is false. Header is used for both reader and writer. If you want a detail about description, you can read this. Inferring the schema. Inferring the schema means it will automatically detect the data types of their column but it is by default it is false. But inferring schema is used only for read, not for write. Okay, enforce schema and about null values, about the NaN values, about the date and time format, and there are so many options. We have a mode option also. When we are handling the corrupt records, we will see about this mode. Okay, if you have some corrupt records, sampling ratio, and there are so many other options. And if you look at the compression, when you are reading a CSV file, there is no compression at all. The compression is not there in CSV file. But when you look at the Parquet file, automatically there is a snappy compression by default in Parquet file. So that's why most of the big data files are converted to a Parquet file, because it is a columnar based, and if you write it into the Parquet file, the format will be compressed. So we have one statistics I'll show you. If you have 1 GB of CSV file, once you write that into a Parquet file, it will be around few MBs of the data. If you convert it to the delta file, it will be around 17 to 18 MB. Okay, we will see about that later on. But when you are converting to a Parquet file, it will take as a compression. But CSV file doesn't compress anything. Your data remains in the same way. So we are going to do all that in the hands-on now. Let us see one example. If you want to read a CSV file and create a data frame, the code is spark.read.csv and pass the path. Okay, so now when you come to your Databricks, I have started the cluster. Yeah, now it is up and running. So I want a data first, because I want to, okay, I'll create a new folder here, new folder, and I'll say that this is all about reader and writer. Okay, writer. In that, I'm creating a new folder. I'll start with CSV file. I'll start with a reading reading CSV file. I'll choose default languages Python and the cluster. So when you want to create a data frame, for that you need a data. Okay, we need a data. So in real time, when you have to read the data is not in your Databricks. It is not in your local machine. Your data is sitting somewhere in the cloud. Your data might be in your ADLS, that is Azure Data Lake Storage. Your data can be in your AWS S3, that is Amazon's Web Service Simple Storage Service. It might be in your Google Cloud. It might be on premises. It might be on data warehouse. It might be on database, anywhere. But for now, let us take a simple example that your data is in your DBFS. So DBFS is nothing but Databricks file systems, where top it acts like a virtual storage for you. So we'll store the data in that. So please concentrate how to store the data. So for this demo, I am using a Formula One racing dataset, circuits dataset, which is a CSV file. Let me go to the data view. I'll control and click on this create table so that I can create a new tab for that. So once you get a new tab, I'll go to this DBFS, and in the file store, in the tables, I will upload a file here, that is a circuit CSV file. So you can go to upload files, that will be automatically set into file store tables. If you want to create a new option, you can create new directory. You can create a new directory, like this is about CSV. Okay, CSV. So this will create a new directory inside a file store, inside a table CSV. Let me click on this and try to upload the CSV file here. You can drag and drop also. Yeah, raw file, and here I have a circuits CSV file. Let me click on OK. So your circuits file will be uploaded here. Yeah, you can see. So you got a path here automatically. But if you go to DBFS, if you click on file store, if you click on tables CSV, you can see here you got a new folder. Inside a CSV, there will be one circuits file. If you right click, you can easily copy the path of that, or you can click here here you get a path. So why we need a path? We have seen in the documentation, when you are creating a data frame by reading a CSV file, you need a path. So the first line is data frame equal to spark dot read dot. Now we are reading a CSV file. That's why we are giving a code like read. When we have a data, we are using spark dot create data frame. Okay, that is the difference. So now I'll be specifying the file format. Look at the documentation, spark.read.csv and path. So here CSV, if it is JSON, I'll mention that it is JSON. If it is Parquet, I'll mention that it is a Parquet. If it is any other format, I'll take an option called format and put it there. Okay, we will see that. So I have given the format or path. I will show you again. So in the dbfs, this is a path. I have copied it and I have pasted here. Now let me execute this. Yeah, it is executing. After that, let me show you. So output, as we know that Spark is lazily evaluated, we need to take an action on top of the transformation. Here read act as a transformation. Now let me use display df and execute this. So if I say display df, your data frame, you can see your data frame. Yeah, so there are 78 rows. You can have a fast statistics here, and there are 8 columns. But hey, where is your column names? So these are your column headers. But we know that when you are reading a CSV file, if you look at this documentation, if you scroll down, when you are reading a CSV file, by default your header is false and your info schema is false. So what do I mean by info schema? So if I want to check the data types, I'll say df dot print schema, and if I execute this, all the data types will show you as a string. But that is not true. You have an integer type, you have an latitude, longitude, altitude, so many different data types, but it is showing you all as a string because the documentation itself says that CSV file inferring the schema and headers both are false. So you need to make it to true. How to make it true? So let me copy this code to save some time, and let me create a new data frame df1. When you look at the documentation here, now you can see data frame dot csv, we have specified the path. We have not specifying any schema. You can see there are so many options. So you have an option that is none. By default it is false, but you can give a header here which is that can be in a boolean. So just focus on this header, that can be a boolean. So how to write that? So when you come here, you write option and you say that hey, the header that should be in a string. Your header should be in a string. How? You can find out from here. Your header can be a string or in a boolean. I mean, you write the header first and then you write it in a boolean or a string. But when you are writing after path, what I mean after path, if you are writing like this, then you just write header and you can proceed. But when you want to write it header outside, you need to give that in a string, put a comma and write true in a boolean. You can give this as a string also, it works. So that is what I am talking. You can use a string, that also works. So spark.read.option headers true. You have to give this option before CSV only, okay, or before the file path only. You cannot give this option after CSV. Okay, you can try that, what happens if I give in that way. So if I have given the headers, when you are giving the headers, just try to see how many Spark jobs you are getting. We will concentrate on this later on. Just you concentrate how many Spark jobs are you are getting. So you can see you got now correct headers. But if you look at the data schemas, like print schemas, I mean the data types of each column, definitely all will be a string. All will be a string. You can see because we haven't inferred any schema. So for now, let me use option and say that your infer schema is also true. Infer schema means it will detect the columns data type and it will print you. Let me execute this, and now you execute this. Beautiful. You can see now it has been changed. Okay, so this is how you can read a CSV file by using an option. There are so many other options in your documentation. Depending upon the use case, we will be using that one by one. We'll proceed further after this. We'll do some transformation, and again we'll be seeing about writer API, how to write this data frame back to a CSV file in detail. Okay, so just think on doing a transformation. So you change the column name. So you try to change column name, and you have the location and the country. I want location and the country on a same column. Change few column names. Let me write it here. Few column names, and location and country should be in the same column. Should be in the same column, and add a new column that should be written as this is F1 data, something like that. So, and you drop a column that is maybe URL. Okay, and drop URL column. So how to do this transformation? Just think on and do it. And I want one more thing. So you add a new column. Add a new column that should contain current timestamp. Let us start with the transformation now. So I will put this all in a comment. So maybe this might be a requirement of converting your data frame and doing some transformation on this. Okay, so first is changing few column names. Just for practice, if you want to rename the column names, for example, this is circuit ID, circuit reference, and this is your name and so on. So let me change the column name of circuit ID to circuit underscore ID. So how to change the column name? You can change the column name by using a data frame function, that is with column rename. So I'll take data frame df dot, let me check what is the name here. It is df1 actually. Okay, so df1 dot with column renamed. So I'm using an IntelliSense control space to get this with column renamed, and you can see the syntax also. It is showing you the syntax, like you need an existing that is in string, and you need a new name that is also in a string. So let me use this, and the old name is your circuit ID. Beautiful. Let me put it here, and I want to rename it with circuit underscore ID. Okay, I will give a new name for this. I'll say df2 and put a equal to sign. Okay, I can do few more things in a same thing, but let me do it one by one so that I can show you. Now if I use display df2 and you can see the renamed column name, you can see here. Yeah, your column name has been renamed. So let me close this. Okay, let me go with the second point. I want location and country to be in the same column. Location and country in the same column. So we can create a new data frame again, and we need to do the changes on this existing data frame, that is df2. So df2 dot with column. Sorry. Okay, when you want to like merge these two columns into one, either you can use select data frame function, or you can go with the with column, also with column function. Okay, so when you are using a with column, you can see here it will ask you the column, the name that should be in the string, and it will ask you the expression what you want to mention in that column. So let me take a with column, and I will say that, hey, this is nothing but location and country, because this column contains location and country. TURY. It's just a practice requirement. It cannot be true in real time. So I want location and country in a new column. So I'll say concat function, and I'll start concatenating the first column, that is location column, and put a comma. Second column is your country name. Put a comma for this and put it in a string. And we know that there will be no space when you run this. So if you want a space, we need to take one more function that is called as a lit function. And you put a space inside that. Okay. So what you get? You get location, that is this location, and a space and a country. So before I want a hyphen, not a space. So I'll put an hyphen like this. So I'll put a hyphen. Now if I want to run this, I want to import the functions of concat and lit. I want to import that. So to import that, let me use from PySpark, excuse me, PySpark dot SQL dot functions import. You can say concat. I want to import concat. I want to import lit. Or rather than importing one by one, you import all the functions from the PySpark SQL. Yeah, it has imported. Now I have getting a new column. Let me run this and let me try to display that. So let me try to display df3. Now you will be getting a new column, a derived column that will contain your location and country. But now I like you may say that I don't want these two columns because I've already merged those columns here. So if you want to drop this, then I can drop that here only inside a data frame 3. I'll use drop, and we know how drop data frame function works. Just pass on the column names here in a string, and that will be sufficient. So you drop the location and you drop the country column here. Okay, let me execute this. Yeah, and let me show you the output now. There is no country column and no location column here. You got a new column, that is location and country. And they have asked you in the requirement to drop the URL column also. So let me drop it here only inside this. So drop URL column also. Let me run this. So your URL column is also dropped. Now you can see it beautiful. Okay. Now you need to add two columns. You need to add two columns. That is adding a new column with a saying that hey, this is F1 data, and you need a current timestamp also. So to add two columns, let me create a new data frame that is deriving from data frame 3 because I want to do the changes on this data frame, that is data frame 3. So if you want a new column, the data frame function is with column again, with column. I'll give a column name. The column name is the data. So what you want in that, so this will be a column name. What you want here, this is nothing but F1 data. So I cannot write this F1 data directly because this should be passed in the lit function. So whatever you write in the lit function, that will be printed. Okay, let me show you. Yeah, so this will take care of getting a new column with a column name called data, and inside that every row will contain the F1 data. So let me run this. Yeah, and let me use display df4. Yeah, you can see here you got a column name data, and this is all about F1 data, F1 data, F1 data. So we want one more column as a current timestamp because current timestamp is a function of like PySpark SQL function. Let me show you the documentation on that. So if you go to functions and if you go to date and time functions, here you got a current timestamp. So how to use it? Very simple. Just say current timestamp and leave it. Okay. So you can create one more data frame, or you can do the changes in the existing data frame only. Again, you can use dot with column, and you say that hey, this is current current time, put a comma. Now you need to pass the function. So what is the function? It is current timestamp underscore timestamp. So if I'm using this, I want to import this. Did I import this? Yeah, you have imported this because we have imported all the functions from the PySpark SQL function. So when you run current timestamp function, let me show you how it works. It has executed. Let me display. Now you will get a two new columns. One is for this with column with a name called data. Second is for this with column and the current timestamp. Okay, so what does current timestamp do? It will print you the current date and time where your cluster is running. Now you can see your date is 7/1/2023 and the time is 4:38:49 and so on. Now don't get confused with this time because this is the time where your virtual machine has been set up, your cluster has set up, that timing is printed here. Okay, so this is how you can make a current timestamp. So this is all about the transformation we have done in PySpark with all the requirements. You can see we have changed the column name, we have merged these two columns, and we have added a new column, we have dropped the column, and so on. There can be multiple requirement when you are working on a real time. Now this is your final data frame. I want to write this data frame back again. So when you are working on a real time, I've told you that data is not in your DBFS. It is not in your DBFS, that is Databricks file system. Your data can be anywhere in the cloud. It can be anywhere in the database or data warehouse. We need to pull that data in the Databricks or in any of the IDE you are working on. Then you use data frame reader. You read the data frame, you do some transformation, and when you are writing it, you are writing back to the target. So your target or your destination can be again your database, your data warehouse, it can be your cloud, it can be anywhere. But now for a practice, we are taking that into our DBFS only. So I'll be writing a new directory here saying that CSV output. Okay, or I'll put that in a CSV and I'll create a new directory here saying that it is an output now. So let me copy this path. So how to write it, how to write this data frame? For writer API we have one more documentation. So let me show you the documentation. So this is regarding the documentation about the reader API. So if you scroll, go back, input and output both are inside the same documentation. This is about reader, and here you got a writer. But in which format you want to write? Hey, I want to write a CSV format. But many times when you are working on a big data, it is not recommended to write in a CSV. They write it in a Parquet file, or they write it in a ORC format, or they write it in a table, because there will be a compression for your data. But for now, for practice, we are using a CSV file. So let me write to the CSV file. You will have n number of options. Again, just like how we have seen for writer, we have n number of options. And if you look at the parameter, path is compulsory. Without path you cannot do anything. Your path can be anywhere. It can be your Hadoop file system, it can be your database file system, it can be your data lake, database, data warehouse, anything. Then when you talk about mode, we will come to this mode later on. Now it is an optional. Okay, we will see in detail about these modes. You can see the extra options. We have already seen this extra options. Now the scope should be for writer. Okay, and I am very much interested on this example. So you just give a data frame name dot write dot csv and just give a path. That's it for now. Okay, so final data frame is df4. So I'll write df4 dot. Now if you remember the theoretical part, I have explained you, when you are deriving a data frame or RDD, we write Spark only for one time. We will write Spark only for one time. You can see that your Spark is written only for one time. We are not using Spark at anywhere in between. When you are writing also, Spark is not needed. We directly use write df4 dot write dot, hey, which format you want? I want a CSV format. And what is your path? So I'll copy the path here, which I have pulled out from here. Okay, so it is inside the CSV directory, but I want one more directory inside that and say output. Okay, so this is output. So what will happen if there is no output folder? A new directory is created in the CSV folder or directory, and inside output you will be getting this data frame or your final data frame. Let me execute this. Yeah, it has executed. Yeah, now it has executed. You cannot see the output. Okay, so let me come here and do some refresh here. Quick refresh. File store, tables, CSV. Yeah, beautiful. You can see you got a output directory here. When you click on output, you got a CSV file. You can see at the end, you can see .csv. So this is your CSV file, and these three are your logs. These are your logs. So we will talk about these log files later on, but this is your file. You can see that this is a CSV file. Now if you want to confirm that, hey, whether this is my final data frame, yeah, so what you can do, you can read that data frame again. You can create, this is data frame check, and you can say spark. While reading we use spark CSV, and you specify the path. So you can specify the same path. Do not worry, sorry, do not worry about the files which are inside this output folder, because in the output we have only one CSV, and these all are the logs. Okay, it will neglect or it will avoid these three files, and it will read only one file. Okay, so don't worry. Let me execute this, and let me show you display. You can use dot show also, data frame dot check, and execute this. Yeah, you can see here. Okay, you put the headers and so on. You got a new data, uh, new columns here, new current timestamp, and so on. Now you might be surprised, like, hey, where are the headers? Actually I had the headers, but when you are writing it, when you are writing a data frame, you did not mention that you want headers. So we need to mention that I want the headers. So if I say I want option, and if I say I want header to be true. Okay, true. But if I run this, I'll get an error saying that, hey, this file is already, or this path already exists. You can see that this path already exists. But how to deal with this type? Then we come into picture like mode. So when you have to specify the mode now. So if you want to append the new content, we go for mode append. If you want to overwrite the existing data, we go for overwrite. If you want to simply ignore the data, we go for option ignore. Yeah. If there is an error, then we go for error option. Okay. So now we already have a data, right? We already have a data. So we are not appending any new rows. If you got a new rows, then we use an option append. Here we already have a data, we need to overwrite it. So I'm specifying the mode. So now you can see how I'll specify the mode. So I'll use option again, option, and in that option I'll specify a mode that should be overwrite. Okay, so there are four types of modes in data frame. While writing into CSV or JSON anything, there are four types: append, overwrite, ignore, error, or error if exist. Okay, if there is an error in your data frame, it will throw you an exception, says that, hey, you have some error in that. For that you need to take an option error. If you want to ignore that write operation, then you can say that option mode ignore. Okay, so now I'm using an overwrite here. So option, I want headers, I am taking the mode as overwrite, and let me execute this. Hey, now it is saying that this file has already exist. Okay, let me change this. I think let me write with like this mode, and let me write it in this way, overwrite. Okay, let me run this. Yeah, now it works. Now it works. So you should not take an option when you are writing a mode. So mode override. Now it has executed. Now let me just have a quick refresh output. Yeah, you got some more logs here. You can see these are all logs, but this is your final data frame. I think you should get the headers in that. Okay, headers in that. So let me execute this. I'm just checking it. Same path, and let me check or display this. Yeah, now beautiful. You can see you got the headers also. So this is how you can write the data frame. So if you want this headers to be true, again while writing this data frame, you need to say option headers true and follow the same path. So this is how we have read the CSV file, done some transformation, and write that again to a CSV file using a mode. I hope you understood this. Thank you for watching this video, guys.
Yes, understood.
Thank you very much. Keep learning.